Alright, this gives you some quick ideas about motion and forces, starting with speed. So a good definition for speed is how fast an object moves. And in terms of mathematics, we want to have a formula that describes that idea. Speed equals the distance moved per unit time. So d upon t, distance over time. Now we can use this equation, d over t, to find out some answers to simple questions as follows. Number one, a motorboat is doing 12 meters per second for a period of 85 seconds. How far does the boat travel during this time? First thing to do is to realize you need to rearrange the equation and make d the subject. So that'll be d equals the speed v times the time t. Notice I'm using v for speed. So we multiply the numbers, 12 for speed times the 85 seconds for the time, and you should get 1020 meters as your answer. And a similar question, except this time we're trying to find the time. How long, for number 2, how long does it take a truck travelling at 16 meters per second to cover 1,824 meters? So we need to have t as our subject of the equation. T equals d over v would be the correct rearrangement. So we're dividing the 1824 by 16, and you should get 114 seconds for the unit in this case. Now, for number 3, a man walks 300 meters in 400 seconds, stops and rests for 90 seconds, and then walks 500 meters in 750 seconds. What is the average speed? Notice the word average for the whole journey. To do this, you need to add up all the distance and find the total distance the man travels, and divide that by the total time that he takes to do that. So we write down VAV for the average speed equals 800, which is the total distance travelled, divided by 1240, which is the total time taken, including the 90 seconds of rest. And you should get 0.65, just the two figures, meters per second. Now the reason we use V for the symbol of speed is because of this concept called velocity, which has the symbol V. So what is velocity? Well, it's the speed in a certain direction. Now we use velocity to define acceleration. Acceleration is defined by the change of velocity per unit time, or in other words, it's how the velocity, the rate of change of velocity with respect to time. Now, as it says in the text here, this also includes any change whatsoever, including changes of direction, because as we just saw, velocity is a concept that involves the dimension of direction as well as speed. So if you speed up or slow down or change direction, you are said to accelerate. A good example of something moving at a constant speed but changing direction all the time is something moving in a circle. For example, the Earth around the Sun, or a ball on the end of a string, and so on. So in that case, you are accelerating towards the center of that circle. Your speed is the same, but because your direction is changing all the time, acceleration is acting. Deceleration is negative, acceleration. The formula now we'll write as A equals change in v over t. This triangle in the equation, it's simply a way, it's the Greek letter delta, which means change in. So change in v divided by t. That is the equation for acceleration. Okay, here's some exercise to try using that equation. Number 1, how long does it take a motorbike to stop if it's travelling at a speed of 16 meters per second and decelerates at a rate of 2 meters per second? Notice there's a small error there in the unit. That should be -2, because of course we just saw that the unit is meters per second squared. So rearrange the equation to find time, t in this case, because we've been asked to find out how long it takes to do something, in this case to stop. The change in velocity will therefore be -16. So -16 down to 0, and of course we must use -2 if it's decelerating. So we get a positive time, happily, of 8 seconds for that. Number 2, just checking your understanding. A motorbike, has a steady acceleration of 3 meters per second squared. Notice that's the clue that tells us the word here must be acceleration. So that's that one. This means that every second, that's that word, its velocity changes by 3 meters per second. Number 3, well, I'll let you have a go yourself, and if you get the answer, v equals 26.04, you know you've done it right. Okay, we're going to be concerned with 2 types of motion graphs: distance time graphs and velocity time graphs. So, first of all, starting with distance time graphs, here are 3 examples. First one is constant speed. And you can see that it's a straight line graph, starting from 0 going up, in a straight line. It does 90 meters in a time of 20 seconds. So we could actually calculate what that constant speed is as v equals 90 the distance divided by 20 the time. To find that out, your calculator should show you 4.5. Next, we have an increasing speed. Notice the slope is continuously increasing. It was about that much to start with, then slightly steeper, and very steep towards the end. That's an increasing speed. And the opposite case for the decreasing speed is shown next door. Fairly high slope to start with, getting flatter and flatter, approaching a flat line, in fact, which would be 0 speed. So here are some examples with a distance time graph as shown. How far does the car go in the first 3 seconds? Well, you just look at the time axis, 3 seconds, and go up to the apex there. You can see, read off the graph, 30 meters is the answer. Number 2, find the speed of the car in the first 3 seconds. To do that, you need to find the slope, or the gradient. Now, that's simply a case of going, once again, using the equation, rise over run, 30 divided by 3. Well, that's the same as distance over time, of course, as we've seen before, that's 10. And meters per second are our units in this case. Number 3, describe what happens between 3 and 5 seconds. Well, you can see it's a flat line there, which means, of course, the car is not moving. Speed is 0. Number 4, draw a line showing the motion of a different car travelling at half the speed of the original car in the first 3 seconds. Well, if it's travelling half as fast, of course, it will go half as fast. So we could put the number 15 on the axis and start our line and end up after 3 seconds on that 15 mark. And that would be the correct answer.